let's take a quick sec to look at how we're going to apply this. This is our magic little triangle here that will always let you know what we're getting to get into in the future, which is today we're just looking at solving for density. And I already told you that density is mass over volume. So there's no mystery there. But the cliffhanger we'll see at the end is, what if I was given density and I wanted to solve for m or solve for v? Because algebra tells me as long as I have two of anything, if they give me density and mass, guess what I can solve? What time? It's late, I'm sorry. Guess what I can solve? I can solve for volume. If they give me volume and density, I can solve for mass. That's algebra. If I've got a three variable equation and I have two of the three, I get to solve for the third. If I have one, I get to do nothing. But two, I solve for the third. So this is a lovely trick, mnemonic device, if you want to call it that, to be able to, in the future, figure out what the equation is without having to memorize how to actually manipulate the density equation to solve for something else. Right now, we're not worried about solving for mass or volume. What I want to do is solve for density. So these are the kind of questions you're going to see. What is the density of a wooden block with a mass of 14 grams and a volume of 23 cubic centimeters? So we don't freak out. We see grams, cubic centimeters, and this isn't much of a mystery because they tell us wide out in the open. Here's our mass, here's our volume. So here, density, this is our unknown. So in any word problem, you start by identifying what you don't know. Then you start plugging in what you do. And I will always encourage you, just like has been done here, in any word problem, I write out the players of the game. So density, mass, and volume are the players of this game. Density is our unknown. That's our question. What is it? So that's our question mark. What's my mass? 14 grams. What's my volume? 23 cubic centimeters. What is my formula? Density equals mass over volume. So density is going to be equal to 14 grams divided by 23 cubic centimeters. What we'll teach you later is with our magic triangle here. If you were to put your hand and you were to cover any of these thirds, that would be the one you're solving for. So if I want to solve for density, I could cover D with my hand. You can't see my hand that's on it right now because you can't see that. I can draw a hand, but I won't. But if you cover density up, what are you left with? M over V. So that's your equation. If you're solving for density, the one you're covering out, I have mass over volume. As we will see later, if I instead wanted to be able to solve for volume, what do I have? M over D, mass over density. So that's a very easy trick to remember how to solve for any of the three. We give you this right now. That's what we're doing right now. But in the future, sweet trick. So right now I have 14 grams of stuff packed into 23 cubic centimeters of space. I'm not asking how I got the measurement. I'm not asking what the different dimensions were or anything like that. I'm given 23 cubic centimeters of volume in this wooden block, 14 grams of mass. What do? I divide it and I end up getting 0.61 grams per cubic centimeter. And that is my density of that wooden block. That looks like dirsity, I know, but hey, that's what you're getting into. So that's how I solve for density, 0.61 grams per cubic centimeter. Why grams per cubic centimeter? Well, here's grams, here's cubic centimeters. Do they cancel? Nope. That means both of them have to be in the answer, 0.61 grams per cubic centimeter. Going back to the previous slide, density of water 1 gram per milliliter or cubic centimeter. Basically, we're going to get to a point where we ask, hey, what floats or doesn't float in water? And basically, anything that has a mass or a density, less than 1 gram per cubic centimeter or milliliter will float. Anything greater than 1 will sink. So if you're ever asking yourself, what sinks or floats in water? Calculate the density, look up the density. If it is less than 1, it's going to float. If it's greater than 1, it's going to sink. Good information to know. Last thing we're going to do here is take a look at another problem, and there's an important step that always throws people completely off, and it's like you've never even done anything before. We are still in the density is mass over volume world. We have another problem, another wooden block, okay? And we have a given mass, and then we also have new information. So it's different. The previous problem said, oh, a volume of 23 centimeters. This one doesn't give us volume, does it? It never says with a volume of. Let's go ahead and figure out what we know. Density, that's what I want, question mark. Mass, 24 grams. So volume, it doesn't tell me a volume, but what does it tell me? It tells me length, width, and height of that wooden block. Those are the dimensions that I need because length times width times height equals the volume of that solid, okay? And in centimeters, that's going to be cubic centimeters of that wooden block. So if I take 4 centimeters times 2 centimeters of width times 2, so you can see that better, 4 centimeters of length, 2 centimeters of width, 2 centimeters of height. That together is going to equal 16 cubic centimeters. So what I did was I had to calculate my volume. I came up with my volume. They did not give me a volume of 16 cubic centimeters. Sorry if that looks rough there. 16 cubic centimeters. I had to figure it out myself, but it wasn't a big deal, was it? Wasn't a problem. I just knew that length, width, height will give me the volume of a solid. These 3 units give me a cubic unit, and they give me all 3. 4 times 2 times 2 gives me a total of 16 what? Cubic centimeters. That is my volume unit for a solid. Yeehaw, and I'm ready to go. So now that I've done all that work, I am now ready to do the simple setup of 24 grams over 16 cubic centimeters, which will then give me 1.5 grams per cubic centimeter. And guess what? That is the density of this particular wooden block. So clearly they're not made of the same lovely wooden substance because there's a lot of types of wood out there. Some are more dense than others. But this particular sample is very different because its density of 1.5 is greater than 1. So unlike our previous example that would float in water, this sample would sink in water because it's greater than 1. That's just something to keep coming back to. Just a little side note for you. So that is the crux of the basic concept of density, how much mass we have packed in a given space. So think of dense things as more compact things. So you can either think of it as same space. So if you have equal volumes, you're then going to have more mass versus another one. So that would be like your backpacks. So if you have 2 backpacks and one person has 10 kilograms stuffed in a backpack and the other is flying super light and doesn't really carry that stuff around, same space, very different mass packed in. So there's less stuff packed in person B's backpack. So this backpack is much less dense than their neighbors. So you could also do identical mass compared to space, as we did with the muscle versus the fat. So muscle is much more dense than fat because you can get the same amount of mass in a much smaller space. And so it's more compact and dense. So in the future, what we're going to do next week is we're going to look at, what if you want to solve for mass? What if you want to solve for volume? This was all density all the time, but it doesn't matter. As long as I have two of my three, I can solve for the missing variable. So if I'm provided with density and volume, I can solve for mass. Density and mass, I can solve for volume. So we'll look at that next week, and we'll look at the floating relationships, how things affect density, because so far we've seen how much stuff we have, but we'll find out that things like temperature and salinity, how much stuff is dissolved in a given substance, can affect the density of a substance. So, saltier water is more dense than fresh water and all this good stuff. So don't get me started on ocean currents. That's my thing. So hope you enjoy this little intro tour through density, and we will continue this journey. Thanks for hanging along with us, and hopefully we're going to be able to get some new knowledge in that brain. Take care.